Hey, Nathan here. Welcome to the last tutorial for the flat paddle series. And in this tutorial, we are going to discuss the GameScreen class and everything we need to do to finish up our game. So a screen needs to be made for our game. It's going to be called GameScreen. That's where our implementation is going to go. All of our entities are going to be loaded into that screen, and that's where we are going to handle our game logic. Once we do that, the game1.cs class needs to be renamed. I usually like to rename it to the actual project name and then add game at the end. Like this project is flat paddles, so I will call that file the game1.cs file. I'll rename that to flat paddles game. And that's the kind of the entry point to our game. That's where we enter our game, and we need to create the new game screen and load that into our screen system, and then our screen system takes off from there. Our program.cs file needs to be fixed to work with PGL2D, and the reason we need to do that is because it auto-generates that code, and it generates it by using a parameterless constructor, which we do not have a parameterless constructor for the PGL2D screens and games. The last few things we need to do is to load the content. I'll give you the resources, the image files, and the Sprite Font file. You'll load those into your project. You'll need to install the Open Sans font. I use a Open Sans font. You can adjust the Sprite Font to use Arial or Times New Roman or whatever you have on your computer, but I decided to use Open Sans. Once we get all that done, last thing, we need to test our game. Make sure we can move, make sure scores are going to the appropriate player, and make sure the timer's working, make sure everything's positioned right. And then I close off the video by offering some recommendations on how to make the computer AI a little bit better or a little bit more random, so it's not so it doesn't look like a computer's playing it. The movement needs to be a little bit less jaggy, so I offer some recommendations on that. The next thing we want to create is the game screen itself. So let's expand our Solution Explorer and right-click Screens and add our game screen. Alright, let's make that small. Alright, so I'm going to add a lot of using statements, and I'm just going to copy and paste, and I'm going to name them off. We need to have using. We need to have using system, using system.collection.generic, using system.link, using flat paddles tutorial.entities, using Microsoft.xna.framework, using Microsoft.xna.framework.graphics, using PGL2D.collision, using PGL2D.game, and last, using PGL2D.gameObject. Alright, so this is going to be a public class game screen, and it's going to derive from PGL2D.screenSystem.gameScreen. Because we named those the same, we need to list it as this. PGL2D.screenSystem.gameScreen. You can change the name of this if you want, like flat paddle screen. That way you don't have to call it this way. Okay, there will actually be no properties for this class. It's just going to be a bunch of private fields. Private ball _ ball. Private. Remember, this is our game screen. This is where our game is actually going to be controlled. Read only UINT. Awarded points. How many points you want to award somebody when they score? Private participant _ player _ computer. private text entity, and this is what we created in the PGL2D series, underscore player score, underscore computer score, and underscore timer. All of our text objects. Now let's create a constructor. Public game screen base game bool accepts input. Bool is frozen is equal to false, and bool is hidden is equal to false. Then we need to call base game accepts input is frozen is hidden. Alright, in the opening and closing curly brackets, let's just set awarded points is equal to 1. Okay. So the constructor, my thoughts are based on you, and your thoughts might differ. The constructor is just going to be responsible for getting our properties and fields in a constructed state. We further need to initialize because we need to load our content, which we should not do in a constructor, and we need to do more stuff after we loaded our content. For example, we need to change our position based off of our texture's width and height. So the only thing we can really set here is the awarded points. Otherwise, we're going to create a public override initialize. We're going to override the initialize method. And there are two methods we want to create, and we want to call in this initialize method. Initialize game entities and initialize text entities. So we initialize our game entities and initialize our text entities. Once those are done, underscore ball.serve. We serve our ball. Alright, so let's go ahead and create those methods. Public void initialize game entities underscore ball is equal to new ball. Color.white. Color.white is, this is the tint color. So color.white is what you see in an image editor is what it's going to look like in the game. Game.absolute center 0, 150. I chose that for the speed. Remember, that speed value is pixels per second, not pixels per game loop. So our angle is going to be 0, and our initial speed is going to be 150. Our maximum speed is going to be 650. What's the maximum our game can travel per second? Our delta speed, how fast we want our ball to increase when it reflects, and the texture name for our asset, ball, which we will load in later. Alright, so we're going to underscore ball.bind entity. We're going to bind the entity to the game.dimensions. Game.dimensions. So we're going to bind it to the game screen. So that's the ball. Var player paddle is equal to new player paddle. Open parentheses. Game.input system. This needs to have a reference to the input system, so we can, if we look at the player paddle, we can query the it's going to be used in the base controllable entity to get the available keybinds. So game.inputSystem, color.white for the tint color, new vector2. I decided to use 100, 200 for the initial position of the paddle. 0 angle. The maximum speed this can travel is 300. And the asset name is just going to be paddle. Alright. So we're going to bind this as well. Player paddle dot bind entity. We're going to bind this to a new rectangle. 0, 0, game dot dimensions dot width and game dot dimensions dot height. Now we can do it this way because the only two buttons we will allow are moving up and moving down, so we cannot move left or right. So we can bind this entity to the entire game window. Var enemy paddle is equal to new enemy paddle color.white, and for the position, new vector2 game.dimensions.right minus 100 and 300 for the Y. We're going to push that down a little bit more than the player. Float math.py. It's going to point to the left. The angle is going to point to the left. 200 for the speed, initial speed. We want to move that a little bit slower to give the player a little bit of advantage because the computer is more accurate. The asset name is going to be paddle. We also will need to provide the rotation, which is going to be the same. Mathhelper.py. The scale 1.0f. The reference to the ball underscore ball. And the bounds we want to bind the object. So game.dimensions. Okay. So that is the enemy paddle. Now those are paddle objects. We need to convert those to participants because our game is wanting participants, not paddles. So underscore player is equal to new participant, and we need to provide the player paddle in there. Underscore computer is equal to new participant enemy paddle. Alright, now those are done, but we need to add those to our game by using the entities list that's provided in our screen. Entities.add underscore ball. So we add our ball, entities.add player paddle, entities.add enemy paddle. So we add our paddle, we do not add our participants. So that is our game entities. Next we need to initialize public void initialize text entities. Alright, so let's work on initializing the text entities. So we created the method, it's empty right now, but we created a public void initialize text entities method. So let's go ahead and fill that up. So the first, we have 3 different text objects. We have the player score, which is at the top left, and that holds whenever you score against the computer that is updated. We have the computer score, which is at the top right, and it's similar to how the player score works. And then at the top center, we have the timer, how long the game has been going on for. And it's a good idea to only create a text object when things change. The way that strings work is that when you create if you call sprite batch.drawString with a quote, it's creating a new string object. So we want to create a new string object if our score never changes from 0 to 1, if only the computer scores. We do not want to create a string object of 0 every game loop. We want to create the string object 0 first, and then use that object as we go. And that will help a little bit. But you don't want to go overboard with this. There is a point where you're doing too much pre-optimization, and you don't want to go too far overboard. Obviously, if you can break down, for example, if you have an algorithm that has 4 nested for loops, when you can obviously do that in one for loop, you want to do that. But you don't want to just go overboard with pre-optimization. You get your code done and then optimize where it needs optimizing, and be smart when you do your code. Okay, so let's get this going. So the way I've set this up is that every time we want to update the text, we adjust the text when the content is loaded and when we update text. And at that point, when the text is updated, we will do certain actions. So we're only going to update the text when we score, and we're only going to update the timer when the game time updates. Now the timer is going to be at the top center. Obviously, a few digits might be wider than other digits. 1 is going to be a very thin digit, so it's not going to take up as much pixels as 9 or 7, let's say. So every time we update text and every time we load the text, we need to reposition. The same goes for the player score and the computer score. At the top left, if we have less than 10 score, we want that digit to be on the far left side of the screen. Obviously, a score of 1 is going to be less wide. It's going to be shorter than a score of 100. That's going to be more width, so we need to adjust the positioning. This is more obvious when we look at the top right. So let's go ahead and take care of this. Underscore player score is equal to new text entity, asset name, game text, the initial string to use, underscore player dot points dot toString, and the color we want the text to be, color.white. Okay, now like I said before, whenever we load our content, which means that content's loaded, that Sprite Font is loaded, we can measure our string, and that's what happens. Whenever that's done, we need to reposition our text, and whenever we update our text, we need to do the same thing. Underscore player score dot content loaded plus equals adjust player text position. Now we haven't created that yet, but that's fine. Do the same thing for text updated. Underscore player score dot text updated plus equals adjust player text position. Okay, so that's it for the player score. We need to do the same thing for the computer and timer. Now the timer, we're going to set that to, I'm just going to copy and paste this here, since it's basically the same thing, just where the computer score, the initial text is underscore computer.points.toString instead of underscore player.points.toString. And then we give it its own adjustment method to be called whenever content's loaded and the text is updated. Now the timer, we're going to set the initial text to be timespan.0. Our game has just started, it's going to be a 0 time. And it's exactly the same format we did for the player and computer. So player score is equal to new text entity. We set it for the game text font that we're using. The initial text we give it is the player's points. We need to convert that to a string. And then it's going to be a color of white. The content loaded and text updated for player score events is going to call adjust player text position. Underscore computer score equals new text entity. Same Sprite Font or game text. It's going to be set to initial text of underscore computer.points, and we need to call .toString for that. It's going to be color.white as well. The content loaded and text updated events for computer score is going to call adjust computer text position. Underscore timer is equal to new text entity. We set it to game text as well. The default initial text it will have is a time span of 0. We need to convert that to a string, and that's going to be color.white as well. Content loaded and text updated for underscore timer. Those events will call adjust timer position. Now we have created all of our text entities. We need to add it to our list. Text entities dot add underscore player score. Text entities dot add underscore computer score. Text entities dot add underscore timer. Okay. So now let's go ahead and create those events. Private void adjust player text position. It's going to be object sender and event args. And what this will do is it will move our text underscore player score. It will move that text to the top left. New vector 2, which is going to be underscore player score dot origin dot x and player score dot origin dot y. So that's going to be at the top left of the game window. Alright, so now we need to adjust the computer's position. Private void adjust computer text position. Alright, that's going to be object sender and event args. Alright, so adjust computer text position. It's going to be underscore computer score dot move. So this is going to be at the top right. So new vector 2 game dot dimensions dot right minus underscore computer score dot origin dot x comma underscore computer score dot origin dot y. So that's at the top right of the game window. Alright, now the last one, private void adjust timer position, object sender, and event args. So this is going to adjust the timer, and we want that in the top middle. So underscore timer is equal underscore timer dot move new vector 2. So new vector 2, we have opening and closing parentheses. Let's create a new opening and closing parentheses. Game.dimensions.width minus underscore timer dot origin dot x. After the first closing parentheses, divided by 2.0 f, comma, underscore timer dot origin dot y. So that will move the timer at the top middle of the screen. Alright, now let's add the update screen override. So I'm going to, overriding members, I'm going to use ReSharper to do that. Update screen, and I'm just going to go ahead and have that generated. Don't need that. That's redundant. And I'll move that to new line. Okay, so we just overrode the protected override void update screen method that we have to override from the GameScreen PGL2D GameScreen class. Now that is going to override the update screen so we can actually perform our logic in our code. Underscore timer dot update text. So we update text by providing the game time dot total game time dot toString, and we need to provide the string format we want to use. So opening double quote so that's minute, single quote colon single quote SS for seconds, end the double quote. So that's going to provide the format as minutes and 2 digits. So let's say 30 minutes or 31 minutes, and then a colon, and then seconds and 2 digits. 31 seconds colon, or 31 colon 24. So 31 minutes, 24 seconds. So we update that. Now, for each var entity in updatable entities, so we only have entities that can be updated. Entity.update game time. Now, I'm trying not to talk about the PGL2D library too much in this video because this should be contained, but I think in the full release, I do not want to have this being dependent on the implementation. I mean, updatable game entities, it should be controlled by the game library. Okay, so for each var entity in updatable entities, so we want to get all updatable entities of type iPaddle. We want to use that interface, and all iPaddle.ofType movable entity. So we want to get all updatable entities of type iPaddle and iMovable. Or not iMovable, but just movable entity. So all of those, which we know we only have 2, we want to check the ball.collision. So ball.checkCollision with that entity. So it only gets... See, if we get updatable entities of type movable entity, that will get the ball as well. So we need to get of type iPaddle as well. If not underscore ball dot out of bounds. If the ball is not out of bounds, we're just going to return. Otherwise, we're going to award points and serve our ball again. Okay. So let's create that award points method. That's going to be private void award points switch underscore ball dot last collision point dot get collision side. That's what I was looking for. So that will get the collision side of when the last collision point happened. Case. If it's on the left side of the screen, the computer one. If it's on the right side of the screen, the player one. So if you didn't watch my tutorial on how to bind an object, that was covered in the PGL2D library, and I also covered that in a game math video, where we're restricting our ball to a rectangle bounds. It cannot go past the game screen. If it hits the top of the screen or the bottom of the screen, it does vector reflection. If it's the left of the side of the screen, the computer scores. If it's the right side of the screen, the player scores. So in this case, rectangle collision side left. So think of the binding box, the whole game window, as a entity, and the ball as another entity. If the ball reaches the side of the game window, that considers that a collision. Like I said, if it hits the top or bottom, it will perform vector reflection. Once it hits the left side, that is a collision. So we calculate that. We hold that reference. Our last collision point is on the left side. We have reached the end of the game window on the left side. The computer has won. Underscore computer dot score. We're going to provide underscore awarded points. Underscore computer score. Whenever our score increases, we need to update our text. So we update our text with underscore computer dot points dot toString. And then we break. And then we need to do the same thing when it's a collision point on the right side, which the player will score. So awarded points and underscore player text or player score dot update text underscore player dot points dot toString and break. Okay. So we know the ball is now out of bounds, so we know for a fact that it has become out of bounds. It will not become out of bounds when it hits the top and bottom. Therefore, if it's out of bounds, it has to be on the left side or the right side. So once we know that, somebody is getting points, so we need to award the points. Then we need to serve the ball again. The last thing we need to do for this file is to override the draw screen method. Let me get rid of this redundant Microsoft X framework stuff. Okay. So, draw screen, it's just going to be very basic. For each var entity in drawable entities, entity.draw game time comma game.sprite batch for each var text entity in drawable text entities, text entity.draw game time comma game.sprite batch. Okay. So that is it for this file. So that is GameScreen. The last couple files, we're going to work on the actual game, which is the game1.cs file, and the program. So I'm going to rename the game1.cs file to Flat Paddles Game. So just rename that CS file to Flat Paddles Game, and then click yes when it asks you to. Alright. So flatpaddlesgame.cs. That is going to be a base game implementation, and that you need to add using pgl2d.game. And pretty much delete everything in the class. Every single thing in the class. And we need to override the constructor. So public flat paddles game, open parentheses, int width, int height, string the content root directory, color, background color, and then we call end parentheses, colon, base, and we call base with that information. So in the constructor, let's set screen system dot add screen new game screen. Now we need to add using flat paddles tutorial.screens. When we call new game screen, we need to provide this and true. It will accept input. Alright, so that is it for that file. Last thing we need to do is look at program. And program, that is now having a problem with our code. Now this is automatically generated, but we're using a different way of handling our game. We do not have a parameterless constructor, so we need to provide the width, height, the root directory, and the background color of our game. So I'm going to choose 720p for the game window, so 1280, 720. Content for the content root directory, and new color, and we need to add using Microsoft.xnet framework. And the color I decided was 0, 100, 100. And that's RGB values. 255 is 100%, 0 is 0. Alright, so that is it for program as well. Let's take a look at our content project. So open up the model game pipeline. If you can't double click this, like I'm not able to double click this, you might have to open it manually. So let me go back to my completed code here and get my content. Okay. So I'll provide this in a zip file in the description, so you don't have to worry about that. To open it manually, I have created a shortcut on my taskbar, and that goes to C Program Files x86 MS Build Monogame version 3.0 Tools Pipeline.exe. So I just click that in my taskbar, and then I have to open the project. So File, Open. Now we need to find out where it is. So let's go back to Visual Studio and look at the full path here. Click the content.mgcb and look at the full path for that. And I'm just going to copy and paste that in open here. So in the file name, I'll just paste that full path, and that should open that just fine. Okay, so like I said, I will give you the content in a zip file. So I'm just going to add existing items. So I want to add the ball. I'm not going to add the guides, actually, because I don't use the guides. I'm going to add the paddle, ball, and Sprite Font. So I'm going to open those three. I'm going to copy the file to the directory. I'm going to do the same thing for the other two. Alright, so those are now copied to my directory. Now, Sprite Font I use, let me double click that. Alright, so the Sprite Font I'm using is using a font called Open Sans. And that is a open source file, open source font that you could use. But it's still recommended that you use the license. And what I did is I created a license file. I copied the license file, told you to use. And at the top, I added what I changed and my copyright. So X and B is determined on how you think about it. X and B can be considered a derivative or an actual just a variation of the work. So I'm going to right click the content folder and choose add existing item. I'm going to add that text file, that Open Sans license text file. So I'm going to add that to my project. Now I'm going to set that to copy to output directory, copy always. So that is included in our final result. So that way we are covered in terms of the license agreement. Okay. So this is the license, and this is what I changed. All right. So we are good to go now. Let's go back to the content pipeline and let's save this. And we will rebuild it. 3 succeeded, 0 failed, so we are good. Now for the moment of truth, let's press F5 and see what happens. See if we need to fix any issues. So we cannot move past the top and bottom of the screen. Our timer is being updated. Vector reflection is working. The computer scored. The ball is reserved. And the computer scored again. And let me make sure vector reflection is working here. It is. Okay. Now you can change how the enemy reacts. That was kind of a... I didn't want to spend any more time on this pawn clone than I needed to. So feel free to play around with how the computer reacts. The ball will speed up the more it's hit. And it does have a maximum speed. So if we close this, we know it's working. Timer's being updated. Our player score is being updated. The computer score is being updated. Vector reflection is working on the paddle, the top and bottom of the screen. If it hits the left side of the screen, the computer scores. If it's the right side of the screen, we score. Everything's working fine. If we look at the ball, whenever it's reflected, it will change. It will speed up by a delta speed. So that's pretty much it for this series. I didn't want to spend that much time on this since it's just a very basic pawn clone. Feel free to change how the enemy is handling the positioning so it's not as jaggy or it's not as 100% accurate. I fixed that a little bit by adding a little bit of tolerance. The width and the width of the ball is its tolerance. So feel free to play around with how it's updating and see if you can make it much better. Player paddle, it only moves up and down. It will move if you're holding down the button. It will stop if you're not holding down any of the buttons, or it cannot move, like if we're at the top of the screen and we're holding down the up button, it cannot move. We have our Sprite Font loaded. I'll put a link to Open Sans. You can get it from Google Fonts. And you can download the license file with that as well, and then you can adjust that for your project. So for now, let's set this to release, and let's build that. Okay. That is it for this series. I hope you enjoyed it. I hope it was interesting to use the PGL 2D library, which handles most of the stuff for us. Next series, we will cover the implementation for PGL 2D, and it will be a space shooter, the flat space shooter. And that's going to be a little bit more interesting. I'm not going to just have it where it throws monsters from the top down. I'm going to have it have a little bit more of a leveling structure, and it's going to be more of a actual game instead of, you know, something we throw up here for an hour. Well, thanks for watching. I hope you enjoyed this. Please give a thumbs up or a like if you enjoyed this. Add a comment if you want to as well. Feel free to take this link and share it, put it on your own site, embed it, whatever you want to do. That's fine with me. Anything that I mentioned that you need resources, be sure to check the description below. There will be links for those. If I missed anything or if a link is dead, please post a comment or find a way to contact me. You can go to my website and use the contact form. Want to be sure that all the links are still live and going. So, stay tuned for the next video.